Hello friends, welcome to our YouTube channel. The purpose of this channel is to help students learn from the comfort of their homes. Yeah, so let's move ahead. The topic that I have for you today is polynomials. It is chapter 2 of class 10. We have done a bit of it in 9th standard as well. So let's build on it. What is a polynomial is the first thing. An algebraic expression is called a polynomial in X if X is not in the denominator, which in other words also mean that the power of x is not negative. X should not be in a root, which in other words mean that the power of x is neither fractional nor decimal. Because in either case, friends, if it is a fractional power, then also it means a square root. And since if it has a decimal power, even decimal power would convert to a fractional power, which would ultimately means a root, right? So these cannot be polynomials. X raised to power minus 2, negative power, not a polynomial. X raised to power minus half, negative as well as fractional power, not a polynomial. 1 by x is in denominator, which can also be written as x raised to power minus 1, so not a polynomial. X minus 3 over x plus 1, not a polynomial. Under root of x cannot be in square root, so not a polynomial. And cube root of x minus 1, not a polynomial. What is the degree of a polynomial? Friends, if you have a polynomial px whose variable is x, then the highest power of x in the polynomial is called the degree of the polynomial px. For example, 4x plus 2, it is a polynomial. The highest power of the variable x is 1, therefore its degree would be 1. 2y square minus 3y plus 4. It is a polynomial in variable y. The maximum power of y is 2, so its degree is 2. And in the last case, it is a polynomial in the variable x and degree is 3 because the highest power of the polynomial is 3. What are the types of polynomial based on their degrees? Number 1, linear polynomial. A polynomial is called a linear polynomial if its degree is 1. Right, so 2x minus 3, cube root of 3, x minus 5. These both have the degree of x as 1, so they are called linear polynomials. Right, a polynomial of degree 2 will be called a quadratic polynomial. For example, 2x square minus 3x. And cubic polynomial. A polynomial of degree 3 will be called a cubic polynomial. For example, 3x raised to power 3 minus 4x square plus 5x minus 6. Right? So there are more polynomials based on the degrees, but we are concerned with only these three types. Right? So linear, quadratic and cubic is what we would be discussing in our curriculum.
Subscribe to our channel and hit the bell icon to continue receiving all notifications as we post new videos.
So what is the value of a polynomial at a given point? If px is a polynomial in x, where k is any real number, then if you replace x by k in the whole of the polynomial, then the value that you will be obtaining is called the value of px at x is equal to k, and it is denoted by pk, right? So for example, if you have a polynomial px and you take any value of x, say 2, you replace x by 2 in the whole polynomial and then you just simplify that polynomial. Whatever answer you get, that would be termed as p2, that is the value of px at x is equal to 2. Let me give you an example. What is the value of px is equal to x square minus 3x minus 4 at x is equal to minus 1? What would we do? We'll simply replace x by minus 1 and solve the value obtained. So we get 0. So therefore p of minus 1 is 0, which means the value of the polynomial px at x is equal to -1 is 0. What is a 0 of a polynomial? This thing we have done in ninth as well. So let's do it again. A real number k will be called a 0 of a polynomial px if pk is equal to 0. Which means, friends, that if you replace x by k in a polynomial and you get 0 as the value of the polynomial at x equal to k, then k will be called the 0 of the polynomial. Geometrically speaking, what does it mean? Geometrically speaking, the 0 of a polynomial is the x coordinate of the point where the graph of the polynomial intersects the x-axis. Let me tell you again. If you draw the graph of a polynomial px, the points at which this graph intersects the x-axis, the x coordinates of those points will be considered the 0 of a polynomial. So this is what is the geometrical meaning of the 0 of a polynomial. Now we need to understand and remember that a polynomial of degree n can have a maximum of n zeros. So a linear polynomial has a degree of 1 as we just learned. So it can have a maximum of 1 0. A quadratic polynomial has a degree of 2. So it can have a maximum of 2 zeros. A cubic polynomial has a degree of 3. So it can have a maximum of 3 zeros. Right? So you need to again remember that the number of zeros that a polynomial of degree n can have at maximum is n, right? It is the maximum number of zeros that the polynomial can have, but the polynomial can have any number of zeros less than n. So giving you an example, suppose there is a polynomial whose degree is 3. It can have no zero. It can have 1 0. It can have 2 zeros. Or at the maximum it can have 3 zeros. But it is not possible for it to have 4 or more zeros. Right? So the maximum number of zeros that a polynomial can have is equal to its degree. But remember that it is the maximum number of zeros. The polynomial can have less than these number of zeros. So let's do the first question of exercise 2.1. The graphs of y is equal to px are given in the figure below for some polynomials px. Find the number of zeros of px in each case. Right. So let me again remind you, the zeros of a polynomial px, geometrically speaking, are the x coordinates of the points where the graph of the polynomial intersects the x-axis. Right. So keeping in mind this, let's start doing this question. So in first figure, you can see that the line that you have drawn for the graph is parallel to x-axis. And since it is parallel to x-axis, friends, it is never going to intersect the x-axis. And therefore this figure or this polynomial can have no zero. So that is why the answer is none. In second figure, the point at which this graph intersects the x-axis is this. There is no other point where this graph intersects the x-axis, and that is why this graph has 1 0. Speaking of third figure, in third figure the graph intersects the x-axis at this point, and this point. So the number of zeros that this graph has or this polynomial has is 3. In figure number 4, this and this are the 2 points where the graph is intersecting the x-axis. So there are 2 zeros of this polynomial. In fifth figure, as you can well visualize that 1, 2, 3 and 4 are the points where the graph is intersecting the x-axis. So therefore the polynomial for which this graph has been drawn has 4 zeros. In sixth figure, this is the first point where the graph is intersecting the x-axis. Now at this point, the graph is just touching the x-axis. And friends, it is also pertinent to tell you that even if the graph is just touching the x-axis, that point will be considered a zero of the polynomial. So number 2 is this and number 3 is this. So overall this graph has 3 zeros. Clear enough? So this is exercise 2.1 that I have done with you. Hope you liked what I have told you and you would have understand clearly. If you have any problem, you can comment in the section below and I'll try to answer all your queries. Right? So
For more informative videos, subscribe to our channel and also hit the bell icon so that you are notified whenever we release a new video. Thank you from Horizons.